January 1945. Somewhere along a frozen European river, a shattered bridge lies in the water, steel twisted, stone burned black. German soldiers are certain the advance has stopped. Then, before dawn, the sound begins, metal clanking softly, engines idling low, men working in the dark. By sunrise, American tanks are crossing where no bridge should exist. If you want real World War II stories like this, subscribe, and comment where you're watching from, because this moment did not happen by chance. Long before American engineers rebuilt bridges in the dark, Europe's wars had been shaped by rivers, roads, and the narrow crossings that bound them together. For centuries, bridges were not simply conveniences. They were pressure points. Armies that controlled them moved freely, armies that lost them stalled, starved, or collapsed. By the time World War II began, this truth was embedded deep inside German military planning. Germany entered the war with a doctrine that emphasized speed, disruption, and denial. Blitzkrieg depended on rapid movement, but it also relied on the ability to slow an enemy once ground had been taken or lost. Bridges were central to that logic. German engineers trained extensively in demolition. Charges were pre-measured. Detonation points were rehearsed. Every major bridge in occupied Europe was studied not just as a route forward, but as an obstacle to be erased when retreat became necessary. This approach worked early in the war. In 1940, as German forces surged through France and the Low Countries, Allied units repeatedly found themselves halted at destroyed crossings. Rivers like the Meuse and the Somme became temporary walls. Delays of even a day allowed German units to reposition, resupply, or counterattack. Time, in those moments, was more valuable than territory. As the war expanded, German planners assumed this principle would always hold. If a bridge was destroyed, an enemy advance would pause. Heavy equipment would back up. Supply columns would stretch thin. Engineers would need days, sometimes weeks, to rebuild what had been lost. That assumption shaped defensive plans across Europe, especially as the tide of war began to turn. By 1943, Germany was no longer advancing. It was preparing to absorb impact. Along the Atlantic coast, and later deep inside France, Belgium, and Western Germany, demolition plans were refined. Bridges were wired in advance. Retreat routes were mapped with the expectation that crossings would be destroyed at the last possible moment. The goal was simple: slow the Allies long enough for German units to regroup and stabilize a new defensive line. What German planners underestimated was the nature of the force approaching them from the west. The Allied invasion of Normandy in June 1944 did not just bring infantry and armor onto the continent. It brought an industrial system. Once the beachheads were secured, the central problem for Allied commanders was not winning isolated battles. It was movement. Every mile inland required fuel, ammunition, food, medical supplies, and replacement vehicles. And all of it had to cross rivers that Germany was prepared to turn into barriers. France alone was laced with waterways. The Vire, the Orne, the Seine. Each one represented a chance for the German army to slow the advance, even as it retreated. In theory, destroying a bridge could force the Allies to halt long enough for artillery to be repositioned, reserves to be pulled back, or counterattacks to be organized. But the Allied war effort, particularly the American one, had been built with this problem in mind long before the first soldiers stepped onto French soil. The United States did not arrive in Europe improvising solutions. It arrived with plans, equipment, and entire units dedicated to solving one specific problem: how to keep moving when the road disappeared. As Allied forces pushed inland from Normandy, the question was no longer whether bridges would be destroyed. That was expected. The real question was how long the destruction would matter. And on that answer, the entire pace of the war in Western Europe would depend. The United States did not view bridges the way most armies did. To American planners, a bridge was not a fragile structure that had to be protected or mourned when destroyed. It was a problem to be solved. Preferably fast. Preferably under fire. Preferably without slowing the men behind it. This mindset was formed years before American soldiers reached Europe. During the interwar period, the U.S. Army invested heavily in engineering doctrine, not as an afterthought, but as a core element of modern warfare. The lesson drawn from World War I was clear: firepower meant little if it could not move. Roads, rails, and bridges were not secondary concerns. They were decisive terrain. American engineers trained accordingly. Combat engineer units were not taught to wait for rear area conditions. They trained to work forward, alongside infantry and armor, under the assumption that the battlefield would not pause for construction. Their equipment reflected this philosophy. Instead of relying on custom-built bridges that required precise measurements and specialized labor, the United States standardized everything. The most important symbol of this approach was the Bailey Bridge. Simple in concept, Brutal in strength, it was a prefabricated steel truss system designed to be assembled by hand. No heavy cranes were required. No permanent foundations were necessary. Panels, transoms, and stringers could be carried by soldiers, pinned together, and extended section by section across gaps where permanent bridges once stood. Lengths could be adjusted. Strength could be increased by layering components. What mattered was speed. Alongside Bailey bridges came treadway pontoon bridges, floating roadways built from steel pontoons linked together across rivers. These systems allowed tanks, trucks, and artillery to cross wide waterways that demolition alone could not fully deny. American units practiced assembling them repeatedly, in daylight and darkness, in calm conditions and simulated fire. The goal was muscle memory. Engineers were expected to build almost automatically, even when exhausted. Just as important as the equipment was how it was used. American engineer battalions were not kept far behind the lines. They were attached directly to advancing formations. Their commanders coordinated with infantry officers and armored units, moving forward as soon as ground was taken. In many cases, engineers arrived at riverbanks before the smoke had fully cleared from the last explosions. This closeness to the front came with a cost. Engineers were not immune to artillery, mortar fire, or small arms fire. Casualties were expected. Losses were planned for. Replacement procedures were in place because commanders understood that delay was more dangerous than exposure. A bridge built under fire was still a bridge. A perfect bridge built too late was useless. American doctrine also emphasized redundancy. If one crossing failed, another would be started immediately. If a bridge was damaged by artillery, repairs would begin while traffic was diverted across a second span. The objective was not elegance. It was continuity. Movement had to continue, even if imperfectly. German intelligence struggled to fully grasp this approach. In earlier campaigns, destroying infrastructure had produced predictable results. Armies stopped. Engineers arrived days later. Temporary solutions gave way to permanent ones. With the Americans, that sequence collapsed. Demolition no longer guaranteed delay. Sometimes it barely produced inconvenience. By late summer 1944, as Allied forces pushed deeper into France, German units began encountering something unfamiliar. Bridges that had been destroyed at night were being crossed the following morning. Rivers meant to anchor defensive lines were suddenly irrelevant. Armor appeared where German officers believed water would protect them. This was not improvisation. It was doctrine executed at scale. Thousands of trained engineers, standardized equipment, and a command philosophy that valued momentum above caution combined into something the German army had not prepared to face. And as American engineers moved ever closer to the front, their work ceased to be invisible. It became impossible to ignore, especially for the soldiers on the other side of the river who were watching their assumptions dissolve in real time. By the time American engineers reached the rivers of Western Europe, there was nothing theoretical left about their training. The front line was no longer a distant concept marked on maps. It was the riverbank itself. Twisted steel lay half-submerged in cold water. Smoke still drifted from demolition charges set only hours earlier. Somewhere across the gap, German positions remained active. Engineer units moved forward with their equipment almost immediately. Trucks rolled up as soon as infantry secured a narrow perimeter. Panels were unloaded by hand. Steel pins were passed from glove to glove. There was no ceremony. No pause. The work began because it had to. Most bridge construction happened at night. Darkness offered limited protection from observation, but it also amplified every sound. Metal scraped. Chains rattled. Engines coughed and fell silent again. Engineers learned to work quietly, communicating with gestures more than words. Floodlights were avoided. Cigarettes were banned. Even a moment of carelessness could draw artillery fire. These were not anonymous laborers. They were young men, many in their early 20s, carrying the same fear and exhaustion as the infantry beside them. The difference was that while riflemen could take cover and return fire, engineers often had nowhere to hide. They stood exposed on open riverbanks, wading into water, balancing steel sections over empty space. Their work demanded precision even as shells landed nearby. Casualties were an accepted reality. When artillery found a construction site, the damage was immediate. A direct hit could collapse partially assembled spans, sending steel into the water and men with it. Medics worked among bridge components, dragging wounded away while construction continued. The decision to stop was rarely made. Every delay risked traffic backing up, supplies stalling, and the entire advance losing momentum. Fatigue accumulated quickly. Engineers often worked through multiple nights with little sleep, their hands raw, their uniforms soaked. Meals were eaten standing. Orders were brief. Everyone knew their task. There was a rhythm to the work: lift, align, pin, move forward. Repetition replaced fear. Discipline replaced hesitation. The proximity to danger forged a particular kind of bond. Infantry units learned to trust engineers not just as support, but as partners. Tank crews waited impatiently at riverbanks, engines idling, knowing that every minute mattered. When the first vehicle rolled across a newly built span, there was rarely celebration. It simply meant the next problem was already forming ahead. German forces began to notice the pattern. Demolitions that should have delayed the advance produced only short pauses. Patrols reported American activity along riverbanks almost immediately after explosions. Artillery fire was redirected, sometimes successfully, but often too late. By the time shells landed, the bridge was already halfway complete. From the German side, the scene was unsettling. Men watched through binoculars as Americans worked in exposed positions, seemingly indifferent to danger. There was no hesitation, no visible panic. When fire landed, the work paused only long enough to assess damage. Then it resumed. This behavior did not fit earlier experience. It suggested planning rather than desperation. For the engineers themselves, there was little time to think in those terms. They focused on the next component, the next connection, the next step forward. Personal fear was managed through routine. Loss was acknowledged quietly, then set aside. The bridge had to be finished. By dawn, the results were often visible. Where hours earlier there had been only water and wreckage, a functional crossing now stretched from bank to bank. Vehicles queued to cross. Supplies flowed forward. The river ceased to exist as a barrier. For the men who built those bridges, there was no illusion about what came next. Another river. Another gap. Another night of work. But on the far side, German soldiers were beginning to understand something unsettling. The destruction they relied on no longer stopped the enemy. It barely slowed him. And that realization would soon reshape how German commanders viewed every retreat, every delay, and every line they believed a river could hold. For the German army, the destruction of bridges had always carried a certain finality. Demolition was not meant to win battles on its own, but to buy time, hours, days, sometimes longer. That time was essential for withdrawing units, repositioning artillery, and restoring cohesion after contact with an advancing enemy. In 1944, German commanders still believed this logic would hold. At first, reports from the front were dismissed as exaggerations. Patrols claimed American vehicles were crossing rivers far sooner than expected. Intelligence summaries mentioned temporary structures appearing overnight. These accounts conflicted with established assumptions, and in a military already strained by losses, contradictions were inconvenient. Bridges destroyed according to plan were supposed to delay an enemy advance. If that delay did not occur, the explanation had to lie elsewhere. German officers initially blamed discipline failures or poor demolition work. Perhaps charges had been placed incorrectly. Perhaps local commanders had detonated too early or too late. Investigations followed, but the pattern persisted even where demolitions were thorough. Bridges were not being repaired in the traditional sense. They were being replaced. This distinction mattered. Repair suggested time, effort, and vulnerability. Replacement suggested preparation. The American approach did not depend on salvaging ruined structures. Engineers arrived with their own solutions, independent of what the Germans had destroyed. From the German perspective, this made destruction itself feel increasingly irrelevant. As Allied forces pushed deeper into France and Belgium, the consequences of this misjudgment became clear. Defensive plans based on delaying actions unraveled. Units expecting several days of reprieve found American armor appearing within hours. Reserves meant to occupy fallback positions arrived too late, or not at all. Artillery units redeploying behind river lines discovered the crossings were already compromised. German intelligence struggled to adapt. Reconnaissance flights were limited by Allied air superiority. Ground reports arrived late, often fragmented. The speed of the American advance outpaced the flow of accurate information. In some cases, German units learned that a bridge existed only when they were engaged by forces that should not yet have been able to reach them. Psychologically, the effect was corrosive. Rivers had long been considered natural allies in defense. They imposed order on chaos, forcing an attacker to pause and concentrate. When those rivers failed to do their job, uncertainty spread. Commanders could no longer rely on geography to stabilize a front. Every withdrawal felt incomplete. Every delay felt temporary. German soldiers on the ground experienced this failure directly. A bridge demolished at night brought brief relief. Morning arrived. Engines were heard. Dust rose from roads that should have been cut. Tanks appeared where water should have stopped them. The sense of being hunted replaced the belief in controlled retreat. This shock did not produce panic, but it did erode confidence. Defensive doctrine depended on predictable enemy behavior. The Americans were proving unpredictable in the one area where predictability had once been assumed. Movement, not firepower, was becoming the dominant threat. By late 1944, German commanders began adjusting their expectations. Destroying bridges was still ordered, but no longer trusted to provide decisive delay. Artillery fire was increased. Counterattacks were attempted sooner. Yet these measures often came too late, reacting to crossings already completed rather than preventing them. The core misjudgment remained unresolved. German planning had been shaped by a belief that infrastructure destruction imposed universal limits. American engineers demonstrated that limits could be engineered around. What began as disbelief hardened into reluctant acknowledgement. The Allies were not simply advancing faster. They were denying Germany one of its last reliable defensive tools. And with each overnight bridge that appeared where none should have existed, the margin for German recovery narrowed. By the late summer of 1944, the pattern was unmistakable. Wherever American forces advanced, rivers ceased to function as natural barriers. What had once been decisive terrain became a temporary inconvenience. The culmination of this shift came not in a single dramatic crossing, but in a series of nights where time itself seemed to bend in favor of the advancing army. In Normandy, the destruction of bridges along the Vire and its tributaries was carried out methodically as German units withdrew. Charges were placed carefully. Spans collapsed into narrow channels, creating tangled wreckage designed to complicate any attempt at repair. Yet American engineers arrived with no intention of fixing what had been destroyed. They surveyed the gaps briefly, marked anchor points, and began unloading prefabricated components almost immediately. Construction often began within hours of the last detonation. Infantry secured shallow bridgeheads on both banks while engineers assembled Bailey panels on the near side. Section by section, the structure extended outward, pushed across rollers, balanced over open water. When artillery fire arrived, work paused only long enough to assess damage. Bent steel was replaced. Lost sections were swapped out. The line continued to grow. What made these crossings decisive was not just speed, but timing. German defensive plans depended on the assumption that an American pause would follow demolition. Instead, tanks and trucks were rolling forward before reserves could reposition. A river meant to anchor a defense line became a liability, compressing retreat routes and exposing units to pursuit. The Seine crossings in August 1944 marked a turning point in scale. The river was wide, its banks muddy, its approaches crowded with traffic. German demolitions were thorough, and the expectation was that the crossing would slow the Allied advance significantly. Instead, American engineers deployed multiple solutions simultaneously. Pontoon bridges floated into position. Bailey spans rose from both banks. Traffic control units managed continuous movement even as construction continued. Some bridges were completed in a single night. Others took longer, but none produced the delay German commanders had planned for. Armor crossed as soon as load limits allowed. Supply trucks followed. Artillery was repositioned across the river while the advance never truly stopped. The river, which should have reset the tempo of the campaign, failed to do so. As the front moved eastward, the pattern repeated along the Meuse and the Roer. Each crossing added pressure to a German army already struggling with fuel shortages and shrinking manpower. Engineers worked in worsening conditions. Autumn rains turned riverbanks into mud. Cold slowed movement and numbed hands. Still, construction continued. The climax of this effort came during the final approach to Germany itself. By late 1944 and early 1945, German commanders understood the danger American engineers posed, but lacked the means to stop them. Artillery ammunition was limited. Air support was sporadic. Demolitions were still carried out, but increasingly out of habit rather than confidence. Overnight bridge builds reached their most refined form during this period. Engineers operated with practiced efficiency. Components were pre-staged. Reconnaissance identified likely crossing points before demolitions even occurred. When explosions echoed across a river valley, American units were already moving. The psychological effect on German defenders was profound. A destroyed bridge no longer provided relief. It merely marked the start of a countdown. Nightfall became ominous. Darkness, once a shield, became a cover for American activity. By dawn, the question was no longer whether a crossing existed, but how much of the enemy had already crossed. In several instances, German units withdrew expecting a pause, only to find American forces pressing closely behind them, crossing rivers almost immediately. The absence of delay collapsed defensive spacing. Units overlapped. Supply routes became congested. Commanders lost the ability to shape the fight on their terms. For American forces, the effect was equally clear. Momentum was preserved. Advances retained coherence. The logistical tail remained connected to the spearhead. Engineering did not merely support the attack, it sustained it in real time. By the time Allied forces reached the final river lines guarding the German heartland, the outcome was no longer in doubt. Rivers that once symbolized defense had been reduced to obstacles measured in hours. The German army's reliance on destruction as a delaying tactic had been outpaced by preparation and execution. The bridges that appeared overnight were not symbols of improvisation. They were the visible outcome of a doctrine executed relentlessly under pressure. Steel, labor, and discipline converged to erase geography as a factor in the fight. And once geography failed to protect them, German defenses had nothing left to absorb the weight of an advancing army that refused to slow. When the bridges went up overnight, the immediate result was movement. The long-term result was collapse. By late 1944 and early 1945, the German army in the West was no longer fighting a series of controlled withdrawals. It was reacting to a pace it could not regulate. American engineering had transformed speed into a strategic weapon. The most visible effect was territorial. Allied advances accelerated beyond what German planners believed possible. Rivers that once defined defensive phases lost their meaning. Units assigned to hold river lines were forced to abandon positions earlier than planned or risk encirclement. In many cases, entire formations withdrew simultaneously, compressing roads and overwhelming supply routes already short on fuel and vehicles. This compression created a cascade of failures. Artillery units struggled to redeploy before American armor arrived. Ammunition stocks were abandoned. Command posts relocated repeatedly, degrading coordination. German commanders found themselves issuing orders based on conditions that had already changed. By the time reports reached higher headquarters, American forces were often across the next river. Supply became the most critical weakness. German logistics depended on predictable pauses in enemy movement to regroup and resupply. Overnight bridge construction erased those pauses. Fuel shortages worsened. Vehicles were left behind for lack of gasoline. Heavy weapons were destroyed by their own crews to prevent capture. Each retreat shortened the distance to the German border without restoring combat power. The psychological impact mirrored the material losses. German soldiers understood that rivers no longer offered safety. Demolitions became symbolic rather than practical. The sense of fighting a losing battle deepened, not because of any single defeat, but because no position seemed capable of slowing the enemy long enough to matter. Morale declined as the war's tempo shifted decisively out of German control. For the Allies, the benefits were equally clear and measurable. Engineering ensured continuity. Supply lines remained intact despite rapid advances. Infantry units were reinforced and resupplied without interruption. Artillery stayed within range. Armor retained freedom of movement. Battles were fought on American terms because the infrastructure behind the front kept pace with the front itself. Reports from the period consistently emphasized this relationship. Commanders noted that advances stalled only when bridges were delayed, and that such delays were increasingly rare. The U.S. Army Corps of Engineers emerged not as a background service, but as a decisive element of combat power. Their work enabled operational plans that assumed constant forward motion. The strategic consequences extended beyond the immediate campaign. German reliance on infrastructure denial was exposed as insufficient against an enemy prepared to replace rather than repair. Defensive doctrine built around delay through destruction proved ineffective against an industrialized force capable of rapid reconstruction under fire. By early 1945, the Western Front no longer resembled the war Germany had planned for. The lines were fluid, retreat continuous, and geography neutralized. Engineering had shortened the war not by overwhelming firepower alone, but by eliminating time as a resource the enemy could exploit. This lesson would not be lost. Post-war military analysis repeatedly returned to the role of engineers in shaping modern warfare. Mobility, once considered a supporting function, was redefined as central to victory. Bridges, roads, and supply lines were recognized as active components of combat power rather than passive infrastructure. As Allied forces pressed into Germany itself, the outcome was already decided. The overnight bridges had done their work. They had carried armies forward faster than defenses could form. They had ensured that retreat offered no relief. What remained was not another battle to be won, but an understanding to be reckoned with, one that would shape how wars were planned and fought long after the last bridge was crossed. When the guns finally quieted in Western Europe, little attention was paid to the bridges that had appeared and disappeared along the way. They were not monuments. Most were dismantled, replaced, or forgotten as towns rebuilt and rivers returned to their ordinary roles. Yet their impact lingered long after the war moved on. The overnight bridges revealed something fundamental about how the United States fought the war. Victory was not pursued through bold gambles or reliance on chance. It was built through preparation, repetition, and an insistence that obstacles were temporary by design. Where others saw limits imposed by terrain, American planners saw engineering problems waiting to be solved. This approach reshaped modern warfare. Mobility became inseparable from combat power. Logistics were no longer hidden in the background, they became central to operational success. The idea that an army could move continuously, regardless of destruction left behind by a retreating enemy, altered how future conflicts would be planned and fought. For the men who built those bridges, there was no sense of legacy in the moment. Their work was measured in hours, not history. A bridge completed meant sleep, briefly. Another crossing meant another night of labor. Recognition was secondary to necessity. The structure either held, or it did not. But history is shaped by such quiet certainties. The war in Western Europe was shortened not only by battles won, but by delays denied. Each overnight bridge removed time from the enemy's grasp. Each crossing carried the weight of an advancing army and the consequences that followed. In the end, American engineers did not defeat German forces through destruction. They defeated them by refusing to be stopped by it. Steel replaced ruins. Preparation replaced hesitation. And as rivers lost their power to protect retreat, the outcome of the war became inevitable. That is the legacy of those nights along Europe's rivers, when men worked in darkness, and history crossed behind them by morning.